You know, I can twist my head for quite a bit before I lose tracking. Ha! Anyway, yes, Loop Dark Snout here with another episode of BackBit Impossible. This time around, well, I've got a problem with my BBT access times. Things aren't as quick on the queue-ups as I thought they should have been. And, well, as luck would have it, I guess, I dig out my old code from Wolves on the Backbit, code that times this wait delay down to the cycle. And things aren't right. And so, well, investigation happens and I come up with reasons or at least theories as to what's going on. So, yeah, I mean, what else can I tell you? You know, blah, blah, blah. So, well, let's just watch, okay? All right.
Now you're probably not going to see much difference here. I realized I was running the original character sets I produced. This is now the merged version. You know, I made some code to merge the characters that all share the same character. So the only thing I had to do is make a new character set. So I loaded that one in with the old video matrix and the old color RAM. And I also tweaked it one more time because on the last time I played this, it was queuing up from the BackBit every frame, which is 32K chunks, because that's just the buffer space I made for myself in between frames. So as you can see, well, I guess I don't think I showed you before, but it was blinking a little more frantically than that. But this time around, it's blinking, you know, every 2 frames. So about, well, what would that be? 12 times a second, I guess. And I got a feeling it'll play a little faster. I set TI string because my stopwatch is in the bedroom, but I realized I did some calculations. Last time around at 5,000 cycles per queue up, it was waiting approximately 45 seconds for it to do all the queue ups. Even though that still doesn't explain why it ran over like 2 or 3 minutes longer than it needed to. So yeah, it's still completely impossible, but I just realized with very little tweaks, I can try different things out because I still want to try out remember the 1K character sets I made? Those might play fast enough to, to get through this file quicker than it naturally plays out. Because I think it's like 6 minutes, 6 seconds or something. If I can get it to play faster than that, well, that's just a little victory, but there's no way I'm going to use that because it looks like crap. And the whole point is doing the impossible with the BackBit. In this case, accessing video, playing it back pretty much at the same speed that an REU can do, almost. Maybe. It's different, and it's definitely memory hungry because I have to run things a lot differently to make it happen. I don't have an REU, but I have seen how they work. And the big thing is, unlike an REU, I'm not limited by 16 megabytes. I think this file goes well over, what is it? Well, say close to 9,000 frames. Well, every 32 frames is 1 megabyte. So that's about 300 megabytes? It's big. Yeah. But anyways, well, when this is done, I guess I'll get to find out how long it took. Thanks for listening to me. Okay. Yeah, the video done, and I hopped out of there as quick as I could. It still takes longer, even with fewer queue-ups, but that's good. It means the way that I had planned to do this from the beginning is possibly the only way to do it. And for fun, here's the SuperCPU version. It's not amazingly fast, is it? It's obviously fast, but not like, whoa! But that's it. Of course, I could have planned this better for the SuperCPU, stuck the video in different banks, and then optimized it for that area. But yeah, come on, that's just dumb. But anyways, neat. I'm also timing this one too, of course. We'll see how long this takes, because that's just why I do things. And the winner, yay! Well, of course, the game is rigged. So here's the version with the 1K character sets. You can tell right away it looks worse, right? Whatever. I'm timing this one also. I expect it to be faster. I guess my original play that queued it up twice every time wasn't 9 minutes. It was probably closer to maybe 7. But still, I guess I could run it again and time it. But whatever. Yeah, cool. We'll see how long this one takes. See you in a bit. This is still the 1K version. I thought of something here. Check out the grass. To do this, oh man, no. But look at it. It's just flickering like crazy, right? Well, it's better when it's a static image. You see how it's just constantly twinkling, right? Even with this guy. Well, the grass is in motion, but it doesn't help that he's moving. But what is on one frame, on the next frame is different. And on the frame following that, it's the previous pixel that was there. Now, this would add considerable logic and time, but I wonder if there's a way to, when a pixel has been set in place by a frame, have it sort of dig in a bit and require a color with a farther away distance than previous that'll convince it to switch. Kind of like a stability factor. I don't know if video compression has this already built in, but it might get rid of these, these insane twitches, right? Like, look at the grass. They're not even moving and it's going nuts, right? Like, look at this. And it kind of looks bad. I wonder. And I wonder that I do not want to go down a rabbit hole that's going to take months to do for nothing really, but oh man, I wonder. And the 1 kilobyte character set was enough to get this through, but I don't think it would be able to play the audio in addition to what it needs to do. Whatever, it was just a trial run. No, it seems the original version I showed you guys was 8.5 minutes. Some investigation is due to occur now. So I had to go and investigate this timing discrepancy. I borrowed my old code that counts the cycles during the wait delay. And it looks like a mess. But there we go. There's the differences. Now the first two, these are just high bytes only. I flipped them around, so this is their actual value. The first two are the slow versions, where the next frame is queued up 128 pages later. And these 2 pages are the results when I queued them up one 64K chunk later. And for some reason, if we add them all up, like all 256 events, because I just had it, do 256 and then loop and then end. But why is it so much bloody faster queuing them up at an even 64K? Now, I've been through this before. That was part 13 of Wolves on the BackBit. The takeaway from it was, as long as you queue stuff up at an even page boundary, you will always get the fastest access. And I learned later on that as long as the value that you're accessing is evenly divisible by 4, you'll still get the fastest time. So this is not making any sense. And I don't know why that is. I thought maybe it was because the data, like I'm queuing up 64K, but the next time around, I'm asking for it halfway through the stuff it already brought in. Does that confuse it? I don't know. I just don't know. But I really don't know what to say about this, because this is, 256 of those. Let's do some math. 450, right? Divided by 256. Well, actually, no, that's pretty much it. Because if you, that is the general amount of cycles delay. Wow. Because if you do that to get to, oh boy. What happened to my 5,000? Man, I don't know. But this would make sense then, because I'm doing, if you're doing this, this many cycles, well, let's do that number, times 8730, and then we'll do the other number. I didn't bother to get the low nibble, I didn't care. And it's not doing 8730, it's only going to do half of that. Oh, jeez. There we go. So what is that? 4365, right? Yes. Because it's only queuing up once at this speed to grab 2 frames. So this turned out to be 3.5 minutes of queue up time, whereas this was a little over 1 minute. That explains why it was so much more. But man, I don't know why this is. This is still my good card. Yikes. Maybe I never noticed it on the Wolves in the BackBit because I was alternating between video stream, audio stream, video stream, audio stream. But then when I had the problems where the audio wasn't playing, it wasn't queuing the audio at all. It's just video, 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 video. I got to go back and see if those queues were still fast. They probably were, which makes this even bigger mystery. Man, I just don't know. Yeah, you've seen this before.
Oh, the water always tastes so good here.
Yeah. So what happened to my 5,000 cycles queue-ups? Is my card wearing out? Is there a reason for it? I don't understand. Yeah, even in this old 6 frames per second nonsense, I didn't make these frames. These ones were done by the RetroPixels program. But you can see even on a static image, more or less, the background is going crazy, right? So, yeah, there's not much I can do to calm down the randomness of the dithering and all that. I don't think I'm going to try. But, yeah, so if I get out of here again and run it, there's that mystery. These used to be 5,000 cycles. I don't know what's going on. Yeah, I think SD cards wear down and slow down. So this is the oh, I can't remember if that's the slow or the fast. One of them is slow, one of them is fast. But look at the differences. Boop-a-doo. Yes. Because, well, I copied. See, I was doing this one. Like this is the file I've been using over and over and over and over. But I made a bunch of backups here because I plan to do the rolled out code, which changes everything, and I'm going to fudge it. I know it, so I made backups, but I never used one. Excuse me. So this time, let's copy the Wolves in the BackBit one, right? Because you saw what I was just getting, the delays. So, and those are faster too. So I cannot rely on this 5,000 cycle queue up. In some cases it's 10. But I'm going to have to sort of bite the bullet on this and go with it that queue ups might be variable, even for me. I thought maybe if I always use this good card, it would always be fast. That is not the case. So, yeah, I am going to have to, be a little more careful. But anyways, well, I learned something else tonight. I don't really like learning this particular bit, but it had to happen.
Well, that light hasn't changed the whole time. I was here, trust me. Nobody's come. I'm starting to feel like that first episode of The Twilight Zone. That was really good. Anyways, yeah. Next time on BackBit Impawsible, we are going to start with the true rollout, the code that creates the code. Because now that we've tested it, we have to make it work. So that's what we're going to do. All right? So till next time, I'm Luke Darksnout.